Welcome to our review on diamond and graphite. So what we're going to do in this video is just have a look at the different properties of diamond and graphite and how those then relate to their possible uses. So thinking about diamond first of all then, we've got to remember those 5 key properties that you can see. So the first one is that it's insoluble in water, so that means it doesn't dissolve in water. Second is that it does not conduct electricity. It's hard, it has a high melting point, and it's lustrous, which basically means it's nice and shiny. So what you've got down at the bottom there, in the bottom left corner, is the diagram they're likely to put on your exam paper of the diamond structure. Now the easiest way to remember this, in terms of identifying it, is as a triangle. Okay, so that triangle in the middle there at the bottom is just to remind you the structure of diamond is the triangular one. In terms of what we use diamond for, you need to know about 2 particular uses. First one is we use diamonds in jewellery. 2 reasons for that. One, it's lustrous, which gives it that lovely shiny appearance, and secondly, it's insoluble in water. It'd be rather traumatic if you imagine having a lovely big diamond ring and you get in the shower one day, get out, have a look at your ring, all of a sudden the diamond's gone because it's dissolved. So because it's insoluble in water, you get to keep your nice shiny jewellery. The second use then is in cutting tools, and the 2 key properties we need to remember there is that it's got a high melting point and it's hard. Basically that diamond ends up on the end of drill tips and the edge of cutting blades, so it's got to be hard so it doesn't just break, and it needs that high melting point because the amount of friction we generate as things are being cut or drilled is very high and we don't want it just to melt away. Now we need to understand why we get a couple of these properties. So the first one that we can see there is the reason that our diamond cannot conduct electricity is because it has no free electrons. So that's the phrase we really need to remember there. If we're asked why the material doesn't conduct electricity, it's because there are no free electrons. Now the other property we need to consider is the high melting point, and the reason that diamond has a high melting point is between each of those carbon atoms that make up its structure there are these very strong covalent bonds. Now in order to break one of those bonds we've got to put a lot of energy in, so that gives it the high melting point. The second material we're going to consider then is graphite. So this one has a few more key properties we've got to remember. First one being it's lustrous. If you look at the picture in the bottom right there, you can see it has that shiny appearance still. It's also opaque, which means it doesn't allow light to pass through it. It's a soft material and it's slippery. It's got a high melting point, it's insoluble in water, and it will conduct electricity. Now in the bottom left we can see again the picture they're going to put on your exam paper when it's asking you to identify which structure is graphite. And the easiest way to remember that is as these stacks of lines. Okay, so if you think about diamond as the triangle, graphite as stacks of lines, it'll help you to identify those different structures. In terms of what we use graphite for then, we've got 3 uses we need to consider. First one is that when we refer to pencil lead, we're actually lying, because that lead inside our pencil is in fact graphite. Now the reason we use graphite inside our pencils is because it's soft and slippery. Kind of important because you don't really want to be trying to write on paper and having it just slice through it, so the soft bit's important, and slippery allows the graphite to transfer from the actual pencil itself onto the bit of paper. We also use it in lubricants, so this is actually mixed in with oil. Now the reason we do that is because it's slippery, so that means it's obviously going to be very good at lubricating joints, and it's got a high melting point as well, so as it's passing through engines it's not going to be affected by those high temperatures. The third use on there is something that we have mentioned going back to our C2 topic in our core science, which is to use it as electrodes in the process of electrolysis. Now the reason that we can do this is it's insoluble in water, so it's not going to dissolve in those liquid solutions, and it will also conduct electricity, which is obviously very important when we're thinking about using it as an electrode in electrolysis. For those higher tier answers we need to understand why it has some of these properties. Now as we've said, graphite can conduct electricity, and the reason it can do that is because it does have these free or delocalized electrons. So hopefully we do remember that electricity, when we've got our current there, it's the flow of electrons. So if we've got free or delocalized electrons available, they can flow through the graphite, therefore conducting electricity. Second one that we've got there, the reason that it's slippery, is if you look at the diagram, you can see those little dashed blue lines represent a weak force that's holding the different layers of the graphite together. Now, because it's only a weak force, it means that those layers can slide over each other very easily. The last property we need to understand is the high melting point, which is exactly the same as we saw with diamond. It's got lots of those strong covalent bonds between each of those carbon atoms, and therefore we need large amounts of energy to break those bonds, and that means it's got the high melting point. So a key word we need to make ourselves aware of and its meaning is the word allotrope. So when we're talking about diamond and graphite, we're referring to allotropes of carbon. So what that actually means is a different form of the same element in the same physical state. So both diamond and graphite are made of carbon atoms, and they're in the solid state of matter. So it's the same element in the same physical state, but they're completely different forms. If you think about the difference between graphite and diamond, you can see how different they can be despite being exactly the same components making them up. The last thing we need to consider is the fact that diamond and graphite are what's called a giant molecular structure. Now, one thing we should remember is that all of these giant molecular structures have similar properties. So what we can actually do is, using what we know about diamond and graphite, we can then apply that to other chemicals we don't necessarily know anything about. So they might ask you about something like sand, which is another example of a giant molecular structure, and ask you what properties it's likely to have. So because obviously it has the same structure as our diamond and graphite, it's got lots of covalent bonds in there, which means it has a high melting point.